All right, so we're live. Scott and Gustav, welcome. There's a lot going on with Elon and his companies. We're seeing some distractions, but we're also going to talk about forget the politics of the spats between Elon and Trump and everything that's kind of playing out in that political drama as Elon kind of refuses to disengage from DC politics. Let's put all of that aside. Let's talk about what really matters. What's happening at Elon's companies, right? We're seeing a few delays. Let's get Gustav back. We're seeing a few delays with Optimus that are really concerning. I'm going to pull up a few posts. Take us through what you're seeing, Scott and Gustav. Here's the first one from the Humanoid Hub. It says Tesla has paused Optimus production to revise its design. The redesign could take around 2 months, according to a Chinese outlet, Late Post Auto. Musk's mass production goal for this year for Optimus is basically out of reach. According to sources in China's supply chain, Tesla is making focused adjustments to the hardware and software design of its humanoid robot Optimus and paused component procurement of the robot for the robot about 2 weeks ago. So we're still catching up with what's happening, right? Take us through what you can make sense of for what's going on before we look at a few other posts.
Okay, so hello, Royden, and right now it's not even 6 a.m. in the East Coast, so I was probably wondering what I'm doing up at this hour, because I'm actually in the same time zone as Gustav right now. I'm still over here in Germany.
And closer to me.
And closer to you, yes. And so I was over here for the Automatica trade show, and based on some of the things that I was hearing there and from other stuff I've heard over the past couple months, this does not come as a complete surprise. I can say it's a little bit of a shock, but not a surprise, because it seems that there's a lot of things that have been happening over the past year or so that seem to indicate that maybe the road to Optimus has been a bit bumpier than we all thought. And we are now starting to see confirmation of that. So this more or less confirms, this is well sourced. So because I've heard rumors from other people, and everything in there, I can pretty much say that, yeah, I have high confidence on the validity of everything that's going in there. Partly because we haven't seen anything to the contrary. And I've been raising some red flags about this, as you probably know, starting last fall, that we weren't really getting the updates we were used to. And a lot of it was sort of sloughed off as well, they don't want the competition to see what they're doing. And as time kind of went on, we began to realize that it's because they really didn't have anything to show. It's not because they were trying to hide anything. And I think this kind of confirms it, that right now we have to do a complete reset on where we believe is the state of the Optimus project. And I think it's in a sense in a disarray. It's in disarray for a couple reasons. The first is there's been an absentee landlord who hasn't really been paying too much attention. And it's been really more than a year. It's been closer to 2 years that, and this is pointed out to me by someone who felt that the best engineer Tesla has been distracted, and it's suddenly gone now. And as we're going to see in some of these other posts coming up, it's not so much that he's distracted, that now he's becoming a distraction internally. And that a lot of times that if you're not there, people start taking care of things, and then when you come in, you start kind of rocking the boat a little bit, and then everyone's going to go in and kind of fix things up. And so what has happened is that the leadership has been basically not setting a good direction and has been tacking back and forth in different directions, and no one really knows which ways to go. Yeah. And it all goes back to that hand. I think we can say that was pretty much when things started to go south.
Yeah. And just for perspective, for those of you watching us on X and on YouTube, so here's my take, and this is not Scott's take. I don't know if Gustav will want to chime in on this, but the way I see it, sitting here in the Middle East, looking at the reaction to everything that's going on from the Middle East and Asia and South Asia, And of course, Scott, right now you're in Europe, pretty much in the same time as Gustavs in Sweden. I feel that our perspective is slightly different from the Tesla fanboys and the Tesla Elon fanboys and the Elon fangirls in America, because I think they sometimes tend to be too close to the problem to spot it. Our perspective is rather unique because we're distant physically, and it gives us a bit of a perspective, and it's cause for concern, because at the end of the day, we're all Tesla bulls, all three of us, and the only thing that matters to us is making the future bright and brilliant, right? The promise of abundance. And if Optimus is going to be delayed because of distractions, then it's something that's, well, less than optimal, right? Let's take a look at some of the other things that were said in this post by Humanoid Hub. Okay, so this is what worries me even more, is that when he says two suppliers confirm that Tesla has not explicitly canceled component orders, but will only confirm a new mass production schedule and resume procurement after the design revision is complete, as we were talking about there. The redesign now could take around 2 months. So that completely throws off skew this production timeline that we were hoping for this year, and goes on to say that as of the end of May, Tesla had purchased enough parts to build 1,200 Optimus units and had produced nearly 1,000. Musk previously promised to produce 5,000 units this year. Now, there's a lot of debate about whether it was a promise or whether it was an expectation. Goes on to say, with a halt in component procurement, both sources believe that that goal is now unlikely to be achieved. And this adjustment started in early June with the departure of Milan Kovac, the original head of the Optimus project. According to one supplier, it's in China, Tesla's VP of AI software, Ashok Elaswamy, has taken over the Optimus project and wants to improve the design before ramping up production. So there's a lot of movement that we've been seeing, Scott and Gustav, in Elon's companies. We're seeing him. Sorry,
Yeah.
go ahead.
In a way, I'm a bit surprised that this is actually an issue, because he has always been split up on so many different programs and
Exactly.
different companies. So at the start, I wasn't really that concerned that a new interest of his would distract. And in another way, the over design of parts is quite common in Tesla and SpaceX history, and in the end they kind of figure it out. The Fabergé egg of the gull-wing doors, etc., of course delayed the production of the Model X quite a lot, and perhaps the hand that they're trying to adapt is also one of these over designed things at this early stage of human robotics.
Yeah, exactly. I mean, do you think, both of you, do you really think the amount of attention that's being paid to kind of perfecting the hand before production begins, of even let's say a 1,500 or 2,000 bots? I mean, we've talked about Gen 1, Gen 2, and Gen 3 of Optimus. Is it necessary to kind of be perfect before you start scaling up production, even start production?
Absolutely not. And that's where I think there was like a little bit of lack of focus of really trying to decide what is the problem we're trying to solve, how are we going to solve it, how do we get there as quickly as possible, to wanting to solve every problem that was out there. And then when you do that, you begin to focus, the hand, if we want to be able to thread a needle. Now, threading a needle is really not that important to the majority of the tasks that you have going on inside the factory floor. You don't need that kind of dexterity. What you need is robustness. You also need a certain amount of grip strength, and you can definitely classify those and improve the original hand design, but without having, I think the pendulum definitely swung way too far over. And it may have been kind of a competitive instinct of wanting to have absolutely the best hand out there, as opposed to having a hand that was like kind of good enough to make the bot overall, the best, because that's what you're trying to optimize. You don't necessarily need the best hand. What you really need is the best bot. And while, and you don't necessarily, that it may seem kind of contradictory, but the reality is there's a lot that kind of goes on in there. And if you focus too much on the wrong thing, you may end up getting the wrong result.
And the whole design choice it has a large potential with the tandem-based system and multiple degrees of freedom, but making it durable will of course increase quite a lot with more moving parts, and tandem-based design is not probably the strongest one we can think of at the moment.
Yeah.
So,
Yeah. But there's a lot going on, and we've got some interesting comments coming in, and I'm just going to pull them up. Shokal Nelson says politicians behaving like criminals, and then he says there was a stage when Elon endorsed Andrew Yang. So there's, we're seeing this strange kind of a combination where you're seeing a layer of political drama, and then internally you're seeing these very real delays and concerns about overthinking the technology, overthinking the product. Let's kind of quickly get back to what we had queued up next. So this is another post from the Humanoid Hub. Let me just pull it up for you. And fix it in a bit. StreamYard has its own little idiosyncrasies. Here we go. So this is a Postway. So this is an interesting shot because this is a K-Scale founder, Benjamin Bolt, saying Tesla has made some bad technical decisions on Optimus, driven by, of course, Elon and his unusual requirements. And this is a little more than the political drama, because we're seeing that I guess in some ways it also reflects who Elon is. He likes to really drill down on something, focus in on something, but at times it's not, it's counterproductive, shall I say. Let's just listen to what this guy's saying.
My case, I think, I guess when I was at Tesla, I was like, my skip manager was Elon. So I saw Elon a lot. Like, I was reporting to Andre Karpathy, and then Andre reported to Elon. So I was like, Elon, he's just like a guy, like he's just like a kind of dorky, like middle-aged guy. So like, there's nothing really that special about him. I could probably do that, but I guess it's like an unusual thing to believe, but like, because there's a lot of like mythos around these types of people, but like, I don't know, like at least I like to try, why not? I mean, Unitree is already shipping a ton of robots. There's like no reason why Tesla couldn't just build a similar robot to Unitree. It's just that they have not done it. And I think the Optimus is very far away from shipping, frankly. It's like there's like I think that realistically the first time you'll have an Optimus in your house will be a few years from now, if that even happens. So it's like, I mean, I would definitely say so. I mean, even, I don't know about the whole shakeup with Milan, but it's like just the way they designed it and the cost. It's a very expensive robot. It costs, over 30K, 40K. I don't know what the price will be if they do ship it. The supply chain is, I mean, I know like a lot of Tesla suppliers, and I know like it's just bad decisions. Like, frankly speaking, and the thing is like with these kind of decisions, like my experience at Tesla was like these decisions are unusually like motivated by Elon. They're either Elon make a lot of the technical decisions himself on kind of core features, or he will like delegate these to people with sort of unusual like requirements, and so like I think it just ends up with a robot that is not very principled, especially from the perspective of like the thing you care about is building a very good machine learning experience into a robot. So if that's what you care about, I think you would design the robot very differently. That's kind of my feeling, is like our robot, the K-bot, is like designed for building really good machine learning experiences, because that's.
What do you make of that?
You want to start, Scott?
Yeah, okay. And he didn't play the final part of it where he sort of talks about, Elon coming to these meetings. Yeah, and let
me go back to it.
Kind of comes down to
it's a bit of a long soundbite.
I don't know. I have a lot of stories about Tesla, but it's like it's not unusual to think this. But it is like I just saw it happen. Like, we would be working on some component of the self-driving stack, and Elon would have some sort of, we go into like a meeting with Elon, and he would just come up with, he would say some like stupid bullshit for 30 minutes, and everyone would have to like nod and be like, yeah, wow, so smart, so good, yeah, and then let's go do that, and then we would like walk out of the meeting, and like no one would do it because he just like very sycophantic, So I don't know. I mean, like, so in that case, like, okay, he's not God. I guess I realized that I was a huge Elon fan before going to Tesla, but I was a bigger fan of Andre personally. Andre was my hero, and he was the reason I went to Tesla. I liked Elon making rockets, but then after I went there, I realized, like, yeah, Elon, he just makes a lot of weird decisions. What he's really good at is getting people inspired to build something really cool. And he builds a really good engineering culture. Like, Tesla was the most fun place I've ever worked. I've tried to replicate a lot of that with how we work at K-Scale. But, like, other than that, I mean, his technical decisions are, I think, not that good. I'm pretty sure I could make better technical decisions. And, I mean, like, we'll just get a product out the door and see how it goes. I mean, I'm not, I'm not going to, like, say that I'm, like, owed anything. I'll just prove it. It's like, but in that sense, like, I don't know. Yeah, he's just some guy. I don't know if this is, like, an American thing. I heard from some VC person one time that, like, going to like an Ivy League school or something. The reason why so many Ivy League people start startups is not because it gives you this technical skill or anything like that. It's because it gives you this, like,
Okay,
irrational sense of
I
self-confidence,
think the rest of
because you
it we
go
can
and have classes
probably
with
cut.
all of these.
Yeah, that's
But I
I
think
think that
that he hits the nail on the head, because, I mean, look, again, he's talking about whether this is an American thing. It just, for the rest of us around the world watching and listening and queuing and investing in Elon's companies, right? It's just, do you need to overthink? Do you need to overbuild? Get the damn thing out the door and then iterate. Build fast, fail fast, and then iterate fast.
right.
What's the
I
big deal?
think it's a little bit kind of lost the way, because the description he had there was like, we all have a boss that's just like that. Everything is fine. Suddenly shows up, decides, to go in, and then, you just imagine papers are flying all over the place, and then you got to kind of clean up afterwards. And that's the danger, kind of being an absentee landlord, is that you're not really on top of what's going on day to day, and suddenly you jet in and you think you know everything, or your requirements change, and that's just not good. It's not good for morale, and it's not good for, like, setting the product direction. So he's
Yeah.
kind of confirming what we've been hearing, like, say, around the scenes in many different places, that it's a bit chaotic. So again, it's kind of gone from the best engineer being distracted to the best engineer becoming the distraction, and not allowing people to get focused. And so, the 22 degree of freedom hand was kind of the beginning of that, because it's not really clear why they wanted to go in that direction, and whether there was, like, suddenly changing things in the middle. Now, I can bring along an anecdote that kind of surprised me a little bit, is that the last shareholder meeting was, I think, about a year ago in June. And at that point, we knew there was a 22 degree from hand coming, but nobody knew exactly what all the degrees of freedom were going to be. And there's a big question between, like, you can figure out the degrees of freedom, that, they're going to be adding a couple more IP joints. There's probably going to be some abduction and some movement like that. But there's a big difference between degrees of freedom and degrees of control. So the question was, were fingers going to be linked together so that it abducted together, or would you have individual motion or stuff like that? That was a big question. I didn't know what the answer was. Nobody knew what the answer was. And the night before the shareholder meeting, I was down at the Clyde Bar, which is why you go to these networking events. And I was recognized by a couple of people who actually had the golden ticket that were going to get the factory tour with both Franz and Elon the next day. And they asked me, it's like, well, if you were on that, what question would you ask Elon? And I was just like, I would ask him, will the 22 degree of freedom hand be able to do this? And they went in and they asked him, will it be able to do this? And Elon's answer was no. And so I said, okay, that means that the abduction is linked together.
Yeah.
Now,
Yeah.
you never know. That it could have been that from that moment when he realized, wait a minute, it cannot live long and prosper.
Yeah.
You may have gone back to the design team and say, we're changing the whole design. You've got to get them all the fingers to move now.
Yeah.
It could be, some simple little things like that. So it seems to me that if that really was the state, and then when we come to the 1010 event, suddenly we are seeing those fingers moving around. I mean, there actually was, you could see it doing this along with playing air guitar.
Yeah.
Now, it's kind of good that we have Gustav here, because he's a hand surgeon.
Yeah.
And knows a thing or two about how hands work. I was very excited, to see the kind of mobility, to see how they're going along there. But Gustav had already kind of recognized, let's say, the inspiration for this hand. And do you want to mention that, Gustav?
Yeah, so I've been looking at prosthetic hands and robotic hands for quite some time, and there is this really it's 13 years old, I think, movement called InMove. I think it's a French artist slash engineer who made this original principal hand called the InMove hand, which later developed into the Parloma hand, which I think we have put up there. And the similarities are quite staggering. They look more or less the same. This robotic hand that Tesla is calling the V3, I think, and the old Parloma hand. And also there, as you were going into there, even if you have the joints and the degrees of freedom, it might not mean that you can actually move it like a human hand. And even in this video that we just saw, you could see the link for the moving the fifth metacarpal, but it didn't actually move it. It's just there, but they never moved that part of the hand. So this is, of course, an early iteration of it. And also you have the joints, but you don't have the intrinsic muscles anymore, which are really important in a lot of our motions, not just opposition of the thumb, but also the independent flexion of the MP joint and extension of the DIP and DIP joints. So I was really intrigued with them going this direction at least, but it's perhaps that also introduced the hand not being strong enough and durable enough. So you have all these different visions of being able to do the Star Trek sign and playing the violin, but if it's going to carry anything heavier than a few batteries, it might break after a few days with the technologies that we have today. So how much are you willing to aspire to and then delay the functioning bot and getting it into doing actual work? It's a hard balance. And as you say, I think Elon has these really nice ideas, I think, and then it comes back to the design team who has been struggling away for weeks and weeks and already found these problems probably, and then he just says, no, throw that out, you have to, now we're going to do this. And at times it makes the rockets land themselves, and other times it blows up a few times.
Hey, well, Elon's not perfect, okay?
Right.
I think the problem is he tries to be perfect too hard.
Right. Now, the thing to remember is that the reason why this is called the Parloma hand is it was a project at the University of Torino, and as you know, depending on how good your Latin or Italian is, Parloma means something like with speaking or communication. The whole point of that project was to actually do sign language. So to come up with a mechanical hand that could be used to train or take text and turn it into sign language. So it means it needed to have very good gestures control. You needed to have those extra degrees of freedom in the metacarpals to be able to come around. You needed, be able to score a 10 on the Kapuni Scale. You needed all of that. And so you needed that kind of control, individual movement, and the abductors, all of it. Now, there's a big difference between
Can you explain the Kapuni Scale for those watching who might not know?
That's basically to look at the kind of flexibility they have in your hand to be able to take your thumb and touch different pads on the different fingers. So starting from here and going on up, over, and then down all the way. And so there's basically 10 different points. And if you can touch all 10 of those points, that means you're able to do like full opposition. You get pretty good control. And that's just a way to be able to tell whether the person has loss of mobility or not. And so that might be one thing you want to do. And I don't think any of the robotic hands out there can actually score a 10 yet. Some of them are like 4 or 5.
The only one I saw close enough was the clone bot with which is a totally different design and mechanics. But they actually, I think they show it actually reaching the fifth metacarpal in one of their videos of a setup. But I mean,
I'll try and pull
that is a way off.
Yes. So it's pretty tricky to be able to, and a lot of it comes down to also the thumb movement. So you may have enough movement in the fingers, even the abduction, but if your CMC joint is inflexible and you can't get over there, that's also gonna be a problem. So part of it is that you get your thumb over, and maybe the pinky is able to kind of come over to complete that task. It's like a little bit of movement. So if you can't quite get there with the thumb, the pinky will kind of help me out a little bit to score that. But the main thing is that there's a big difference between playing air guitar and then having the finger pressures to be able to push down on the frets. And so we were able to see it can play air guitar pretty well, but the question is whether it can actually apply enough pressure, grip strength. That is really what's important in the robot. And based on that post that Humanoid Hub had, which it appears that the fingers do not have enough grip strength. And there's a lot of reasons for why that's going to be the case. So again, if it's going to be doing useful work, that's the name of the game, the grip strength. I really don't care about it being able to have a lot of dexterity and gesture control. It needs to come down to the grip strength. And that's one of the tricks with tendon-based control, is that they're losing all kinds of mechanical leverage and advantages. And a lot of it comes down to, if you get too much mobility in your fingers, your grip strength is going to fail because your fingers are going to slip. Now, we've already seen another hand, which is about a 22 degree or 20 DOF hand, which is also a tendon-based control from 1X. And we've seen a lot of videos from all the different companies. And this is the one thing I always point out is, don't pay attention to what they show you. Pay attention to what they don't show you.
Yeah.
So, yeah, 1X had an unboxing video a couple of months ago from a company called Nothing. It's the Nothing phone, and they went ahead and showed it, and it was a pretty impressive video and everything that's going on. But if you look really closely, you begin to realize, wait a minute, there are some sequences we're not seeing that clearly were set up by a human because the hand couldn't do it, and you were just seeing the rest of what was going on. And one example in there was the phone being dragged across the table, and then the next thing you see is the phone in the hand of the bot. What you didn't see is that whether it could actually get the fingers underneath the phone to lift it off the table. You know, it wasn't shown there. So I was like, that's actually a tricky, very difficult thing. You'll see other things like with some of the 1X videos where Neo comes to the door to receive the groceries from a human that's just come back from the grocery store, and then you see the grocery bag, and then it cuts. You never actually see the bot grab the groceries. You begin to wonder, well, why? Is it because it doesn't have the balance control? It doesn't have the grip strength and everything else? And these are some of the same things that we've been seeing, is that we've seen some of the stuff that the hand can do, but we're not really seeing it doing anything really useful. The closest we saw was grabbing a tennis ball, and that's it. We have not seen anything else. So there's lots and lots of things that are kind of missing right now, is being able to see the capabilities in what these hands can do. So again, going back to the 1X video, one of the issues that they had was they wanted to pull off a label. As soon as they pulled that label off, you could see the fingers slip. And now, in order to change that, they went from their original design where they had complete movement in their thumb. So their thumb was able to move around to where they locked that CMC joint. So I think, Gustav, you say the medical term for that is that they had a sloppy CMC joint. Is that right?
Yeah, it was at least not very stable. So they had to do an arthrodesis of the CMC joint to get us.
Exactly. So they did a fusion to put it in there. So the thumb could only do that kind of movement. And even then, because they have like movement, the abduction on the finger here, that when they applied too much force, it would slip. So I want you to think about it for a second. What Tesla has done is that for control of the finger, they've got 4 different tendons in here now. They have a flexure to make it close this way, and they have an extensor to pull it back. And they've got a joint that's going to be going there that allows it to pivot around, just like in the Parloma hand. Then there's another joint going perpendicular to that to allow the abduction back and forth. And they've got a tendon on both sides to pull it either to the left or to the right. So the abduction and the adduction is going on there. So that means they actually have 4 different actuators doing it. And these are linear actuators. They're actually pulling, tugging on these tendons. And you have to hope the tendons don't creep or have any other kind of movement. Now, what can happen is that when you are pulling down on the flexure, in the ideal world, when you pull on that, it's only going to do this. Your finger is only going to flex forward. In the real world, that tendon is coming around and twisting and everything else. It's going to apply a slight moment on your abduction. So when you pull on the flexure, your finger is going to abduct this way, or it's going to move one way or the other. That means the tendons you have on there are going to have to maintain some sort of tension to keep it locked in place. Otherwise, it's just going to flop around. You have to do that. And what is what's going on with the tendons is, remember, they only work in tension. They don't work in compression. So it's like trying to control a horse that wants to move its head back and forth. You've got these reins. And all you can do is like pull on the rein. You can't push on the rein. You can relax it a little bit if you need to. But reality, your only control is like pulling it back and forth. And you've got a horse that's deciding it wants to move its head around like that. Good luck trying to do that. That's basically what's happening when they're coming down with flexion, is it's moving back and forth. Now, apply a force up here. So I've got a pin joint right down here. All I have to do is apply a little bit of force there, and I can create a very large moment right down here. There's a big torque that's going to happen when I apply that. Right down here, I've got these two tendons that have a teeny tiny lever arm that they are using to control the position of that down there. It's probably a factor of 10 or 20 difference in that lever arm. Doesn't take much force. And so whenever you're trying to grab something, there are forces going in multiple directions that you're trying to control. That thing is flopping around like crazy. So they're finding it's hard to control that. And if you want to kind of get an idea, is that mechanically they get the hand, they're able to show the hand doing all the stuff, basically playing back different gestures that they've done. But the control is very difficult. And there was a post from Ashish back in April, who is one of the members of the TeslaBot team, when they were talking about the RL learning that they had just done for Optimus. They finally were able to do RL walking. And there was all sorts of excitement. They already have that in there. And if you read it, I think it says something like, in the coming months, if you can read that one, say, we are planning. Yeah, I think it's the second paragraph. Just read that out loud, Broyden.
Unmute
It says, we are planning. Yeah.
We're planning to extend our RL sim training to manipulate in the coming months with 22 DOF hands. Initial results would produce dexterous robot specialists. My team is also building a generalist robot policy by leveraging robot and generic internet video data. Okay,
when I read that post, I nearly fell out of my chair because it was a red flag to me. That I was like, holy cow! It's like, we are planning in the coming months to start applying. They haven't been doing anything to get the actual control in the learning of that. So that told me that they're way
was from the 2nd of April. This was from the 2nd of April.
This is the 2nd of April, yeah. And
by then, we had already seen Figure do some amazing things with Sim to Rail.
Yes. So this was basically, there had been a 4-month loss of signal coming out of the Optimus team. So we didn't get any updates in January, February, most of December, absolutely nothing. January, February, March, and suddenly the 1st of April, Elon comes in to check in on the team, and then he shoots that with his cell phone and puts it out there. And that was like the first RL learning. Now, everyone was sort of excited about the fact they had the walking on that, but it was not walking any faster than they already were. And it really didn't look that much better or more impressive. In many ways, there was some things about the stride that I could criticize with the way its toe off was happening, and some of that I do not think was actually improving it, but it seemed to be more drunk than before. And then that resulted in some of these other posts of just like the excitement. We finally cracked RL to figure out what's going on. Now, the K-Scale video that we just listened to, so the founder of K-Scale, he came out of Tesla, and remember, he commented about that I would design a bot that would be better for machine learning.
Yeah,
that's part of the problem, is mechanically the bot is too complicated for the machine learning. This is why they were very long. Again, Jim Fan kind of pointed out this idea of design for simulation. You better design your bot to work in RL, or you can kiss, RL goodbye. Basically his quote. And so it's the same sort of issue. One other thing I will point out, that he mentioned that, they should be pumping out bots, like Unitree. Unitree was able to build a lot of bots last year because their bot is a toy. Okay, the actuators and everything are not serious actuators. They overheat very quickly. They fail very quickly. I mean, everyone I've talked to that's using it, it's just okay. It's great for us to get an idea of what we might be able to do with the humanoid, but this is not the humanoid we're going to use because it's just not reliable enough. So you can pump them out scale, but they're not going to be reliable. So this is like the big difference that's going on right now, is who's going to be producing the robust robot, the serious robot. And Tesla has been trying to do that. But the thing is that even they are finding it hard. Even they are having overheating issues. Even they are having mechanical design issues. Even they are having issues with the RL learning. And now they've just figured out how to get that bot to walk. And now they want to apply it to the hands, where they have actually, even though they get 22 degrees of freedom, it looks like they've got 24 actuators. So I don't know how you can have more actuators than degrees of freedom. And the reason is because for positive and negative, you need 2 motors to do that. Now, there is a way to solve this problem, and I saw at Automatica at Agile, they showed a hand that was sort of a hybrid tendon-driven hand that also was mechanical. And so they had these fingers that it was like all in one kind of finger. Everything is in there, and you can stack them together. And it clearly had a flexure, and it had an extension, and you could see down the finger where they had the motors there to wrap it up and move it around. They also had abduction, but they did abduction with one motor. And the reason why they were able to do it with one motor is that was purely mechanical. They built with almost looks like a differential in your car, where you have the conical gears that are in there. So they had one motor, and because it was mechanically linked and not with a tendon, one motor could give them both directions. Whereas with tendons, you need one to go this way and one to pull yourself back. The other advantage doing that with the abduction, having mechanically linked there, it means when they get to a position, they can hold that position. They just lock it right in there, and they don't have to worry about forces making that thing flop around. So you may start to see different approaches, and you're seeing more and more hand designs tending more towards the mechanical kind of linkages as opposed to tendons, because it will be easier to control, easier to lock into position to be able to get that grip strength you're going to need.
Yeah.
And I would get
Okay,
closer
so
to the
Scott,
human anatomy as well, with a mix of extrinsic and intrinsic muscle, where the extrinsic could be tendon based, a lot of them, whereas you have the intrinsic muscle ones doing the small abduction, opposition, and whatever, with the small mechanical motors, because these are small muscles, but they are highly sensitive to changes in pressure and forces acting upon them. But then we haven't even started talking about the shearing forces that the finger needs to react to not lose grip of things and so on. But that's a totally different beast, I guess. Perhaps these mechanical motors will be better at that.
Yeah.
So we have
shearing force is kind of what we're talking about. Is that it's that side force is making the abduction move around, and the other thing is the shearing force you have to measure somehow. So either you need something that can tell that shear is going on there, or you're going to want to have some sort of sensors on your fingertips to be able to know that. And that's going to be very important when you're holding onto a bottle and it starts to slide down, is that normally you're not going to notice that the bottle's sliding down unless you see it. But if you're looking away, you're not going to feel it. But if you have some sort of sensors on there that's not a pressure sensor, but actually is that shearing, then you're going to, I need to apply a little bit more pressure right now to keep that bottle from slipping out.
Right. Okay, we've got a couple of questions from people watching us. I'm just going to pull up one. Ashoka Nelson asks, are the actuators made of titanium? And he's got a supplementary question saying, what's the expected life expectancy of the actuators? They're going to be under enormous strain constantly.
Yeah. Okay. So it's kind of the industry norm, which would be about 10,000 hours mean time between failure. And that means if you're using it, 24/7, that's about a year. So that's now they may go higher. I know like a lot of industrial robot arms have like around 60,000 mean time between failure on them. So they eventually get there, but it drives the cost up. And right now, they cannot pump out the high quality actuators at quite the speed that you want. I mean, these are some of the things I've learned from the suppliers going on there, is that while there's a lot of components they can put together pretty quickly, there'll always be like these one or two components that require a lot of time. And so for instance, if you look at a harmonic drive, it's made up of a couple different components. You get an interior component, which they call the wave generator. It's basically sort of an elliptical shaft that rotates around, and then it's inside of another very thin kind of gear that's the flexi spline. And because it's elliptical, it kind of goes around and causes that flexi spline to distort. Now, those can be made using kind of normal processes, and the teeth that are in that flexi spline can also be made with normal hobbing kind of process. But then there's another part that goes on the outside, which is called the secondary spline, that goes on the outside of that, and that's the actual part that starts to turn around. The requirements for that are much higher, and so it can't be made with the normal hobbing process. And right now, they're actually using EDM to produce these parts, and it will take them about 45 minutes to make one of those, to make it all the way around, because of the precision that's required and the fact that it's made out of a hardened steel. And the other part of a lot of these processes is that they are using extremely hardened steel, and it has to be hardened before the process, not after. Okay, because if you do the hardening after, suddenly you lose all your dimensionality. And that means the manufacturing times are a lot harder. Now that's just for a harmonic drive. For rotary, you have similar issues going on with a linear drive, that the inverted roller screw that they have is the same thing. It's made out of a hardened steel. And the time to actually produce that, it's not as simple as just saying, take it and then run a tap through it, and then I've got my threads. Again, it's using a very precise CNC kind of machining process that takes about 45 minutes for each one of them. So that means if you have only one machine, if you have only one machine that's producing that, you're making what? Maybe 24 a day, call it 25 to make it a little bit easier to calculate. And then, take this, like, how many of you getting out of that in a month? That's a small number. And then you start to think of, well, wait a minute, I don't need one actuator for my bot. I need like at least 30 of these, the structural actuators that are going to be in there, 30, 32. So suddenly you begin to realize, holy cow, it's like in one day, I can't even produce enough components for the actuators that are going to need for one bot. Now, if you solve that through having a parallel process, you don't have one machine that's producing these parts. You try to get as many of those as you can, but you've got to scale them up. So it's not a question that the supply chain right now says, well, we'll just dial it up to 11 and we'll be able to have them come out faster. There's a limitation to how quickly they can manufacture these parts, especially right now. They haven't been told to go to scale. The dimensions and everything is changing, so they're not willing to invest in the tooling that may allow them to make it go faster. And they've told me, it's like, yeah, it's like, we can scale this up. We can get those 45 minutes actually down to 5 minutes. We've got other processes we're looking at, but right now we need to have like the guarantees to be able to do that. So right now the numbers coming out are pretty slow, and the only way you can increase that is you have to have more and more of these machines. So you got this EDM process that's going on there. Well, we just got to buy a lot of EDM machines, and then we can start pumping out more and more. But it's still costly and it takes a lot of time. And after finding out exactly what that was, I had done some research that indicated to me that might be a problem, but then actually talking to a couple of the suppliers that are working on that and them explaining that whole process to me, it was like, oh yeah. I mean, this idea of hitting 5,000 this year was a fantasy. There was like no way they were going to be able to produce enough parts to be able to do that. Next year, it may be possible again, if the signals kind of go out there and allows the supply chain to go up. But I think you could only then be looking at in the order of 10, 15,000 units next year based on the ramping on that. The year after that.
You mean by the end of next year?
By the end of next year. So what could happen is that potentially, if there wasn't all these bumps in the road, that by the end of this year, they could reach a scale that they are at a production rate of 10,000 a year, but not for 2025. And my overall feeling is it was going to be low thousands for 2025, just because they would not have everything ramped up, and they potentially could hit 10,000 next year. And that seems to be kind of
if your customer doesn't contact you and say, oh, pause it, we're going to change the design. Yes. And now they've started buying this expensive machinery to build the components. So, I was thinking, is this article kind of the suppliers being a bit upset and like, okay, they treated us badly, let's put this out there to kind of get back at them? Or am I thinking to...
I'm going to go even more Machiavellian than that.
Go for it.
Okay, so I had my qualms about the 22 Dauphin. As great as it was, I was assuming that they definitely knew a lot of things that I didn't know, and that they were very confident they could move ahead and be able to do that. Knowing that, and you heard me say it many, many times, tendons are finicky. That's a problem they're going to have to try to resolve. One of the ways of resolving it is that by going to linear actuators, that was a little bit better, because if you take tendons and you run them around spool, that just makes it worse. And it also takes up a lot of energy. So if you're able to pull them like that, that might be one part of the solution, but there's still a lot of issues that are going on. And I assume that they had more of the machine learning aspect under control, and now it seems like maybe they didn't have that quite under control as we thought. But still, I knew that there could be some issues bringing up, and I actually told Herbert back in November. I said, they might have real big problems with this, and it's going to come back to bite them, and there's a good chance that Milan could be gone by June. That's what I told him back then. I do not take any comfort that I was right. I was obviously concerned by the 4 months that we weren't hearing anything, that we weren't seeing any progress, and that the concern was everyone keeps on saying it's in production, so we've only seen it doing something on the battery. What it's doing is not very impressive, and then we get confirmation from here. It's like, yeah, that's all it's been doing. It can't even do it at human speeds. So those, I mean, a lot of the things that were concerning, we're finding out right now. There is no new head of the Optimus team. Basically, it has been put onto a Shocks plate. He already has more than enough on his plate right now. He's trying to get Robotaxi going.
Yeah.
He's a software guy. He's not a mechanical guy. He's not a production guy. So suddenly now he's thrown in a position that's like, wait a minute, I've got to deal with a hardware problem here, and I'm going to talk about production. So either, you know, it could be that a lot of people say, wait a minute, let's make it very clear what he is inheriting. All right. Yeah. Let's just basically say this is the current state. So you know what he's got to deal with right now. And that's what I'm saying, is that I don't think it's these vendors necessarily wanting to air grievances. I think they were greenlit to go ahead and leak some of this information, because it's interesting that it came from a lot of different directions all at the same time, and everyone's story seems to be the same. So it's more or less like this is how you kind of control the narrative. If it's very clear, because everyone was saying something's wrong, so you know, something is really wrong, and you can either keep denying it, or you can just say, all right, let's suddenly get the record straight. This is kind of where we're at, and we recognize that there's some issues, and we're start moving ahead. And as you've seen there, I mean, as far as the hand, the person who was also the lead on the Optimus team for the hand, he left about 2 weeks ago for OpenAI. So again, there had been a lot of people leaving the team, and you know, maybe there's going to be some fresh blood coming in or reinvigoration, but what that remains to be seen.
I mean, still Tesla has the scale and the like the, what do you call it? They have the opportunity to. They're still the most popular company to work for, at least by expiring engineers. Perhaps they will change in a few years.
Is really, really strong, isn't it? I mean,
and I mean,
Gustav was right. I mean, what they had some. Like, they've been having hundreds of thousands of applications every quarter for people dying to work for them. Elon's companies are still, I mean, number 1, 2, and 3 on the wish list of engineers getting out of college. So there's no dearth of talent, but I mean,
and also the manufacturing, not just the skill, but the actual scale. I mean, they have the funds to build these things. I'm thinking all of these minor startups, they will have a real hard time raising the cash or the capital to kind of push these out, because I think you need to build a few 100,000 to actually start making them, like making money out of them. I don't see a company building 10,000 bots a year or 10,000 bots a year actually making a profit unless they are really, really good at
so when you say sell, are you talking about leasing to other companies for production lines, etc., or are you talking about selling to home users?
Yeah, any of it. I mean, to build, let's say it costs $500,000 or the Swedish, sorry, 50K to build one of these bots, to manage to get that capital to get up and running before you can supply them. I mean, Figure is now testing in BMW plants and so on, but I don't see them making any money out of those bots. I have a really hard time, aside from BMW kind of investing in them to build more bots. But I mean, the cost of manufacturing one of these humanoid bots must still be extremely staggering. And before you make that money back, you have to reach scale, right? Or will it be enough to sell 100 or lease 100 bots a year? I don't see that.
It's you'd like to have like 100,000. You ideally don't want to sell them. You do want to lease them. The number has always been you could probably lease them for about 100,000 a year to these manufacturers. And if If you have 100,000 of them, I think it's about 10 billion right there. So that means that's decent cash flow. And if you scale up from that, and you get it to the 500,000, well, now I would just put a 5 in front of that, and you'll be able to scale a bit more. Where I think there may be a little bit of loss of focus is everyone says, oh, we want to get it in the house. It's going to take a while to get into the house because the bots just aren't safe enough right now. It's going to be a while before you get there. And I get the feeling everyone is trying to run before they learn to walk.
Yeah.
And start, keep it simple, start proving yourself in an environment where you can not only get good training, but potentially get the cash flow that will keep you afloat so you can then make that next leap. The first thing is going to be that the robots are capable enough to do the job in kind of an enclosed environment, and then figuring out how to make them safe enough to work next to humans. Maybe not safe enough to go in the home, but at least you're already figuring out how do we make these things a little bit safer? How do we verify that they are safe? And then you can start to move into the house. But if you're trying to go into the home too soon, that's where I think you start to lose your lack of focus, and why you've got, you're basically pulling on too many threads. You've got too many requirements that you're trying to meet, and what they need to do is stay absolutely focused on what's going on there. What is the hand they really need? What is the hand they need to get it working in the shop right now? How many degrees of freedom do they really need? How robust does it need to be? How do they need to control it? It's already difficult enough to control a bot that has, the original bot where they had 6 actuators on there. So that's already, challenging enough. Master that. Figure out how to control that with a limited number of degrees of freedom, with a limited number of actuators. And once you are good at that, then you can start saying, let's double, let's triple, let's increase the number that's going on in there. But I think that's the problem, is that they pretty much chased after too many degrees of freedom way too soon.
So in the end, it was all your fault. You asked
It
for
was all your fault.
for
Your
the
fault,
exactly.
Scott.
salute, and they're like, okay, let's do that.
Yeah,
You sank
yeah,
the ship.
it is, and it's
Scott is
Yeah,
a
there-
bot whisperer.
there's going to be arguments back and forth on what everyone wants to have. A lot of people think you have to have a fully dexterous hand. That's the way you get to AGI, is that you need to have a hand. It needs to have all sorts of touch sensing and everything else. And that's really nice to have, but the question is that an impediment to getting to that goal? If you try to design that too soon without understanding enough about what really goes on in making a hand that's going to be able to move, be able to grasp, and do very simple things. My design principle has always been basically Pareto's law, is like focus on the first 80% that you can do with 20% effort. Cover the maximum amount. Don't be distracted by that last 20%. And this has been the problem. Is a lot of times people get too distracted. Someone comes in and says, "We got to have this functionality. We got to have this functionality," and no one questions, "Do we really need that? And how much effort is it going to take to get there?" Just knock out that first 80%, and then from that, you will learn everything you need to know to get that last 20%. But if you try to solve that last 20% before you've done the first 80, you have no idea. You don't know how hard that is. You don't know how it's achievable. You don't know how to manage it. And then you can start getting next generations of the bots coming out here. And I think it's another thing we haven't really talked about, is like that whole Gen 3 has been like some kind of unicorn that we've been chasing after, because that was first mentioned last spring. And I don't mean the spring of 2025, I mean spring of 2024, that it was something that we should see the Gen 3 bot by the 4th quarter of 2024. And we never saw a glimpse of it. It was never there. And then the closest we've seen is in the shareholder deck in the last quarter of the production line. And that's not the Gen 3 bot. that is the Gen 2 refresh with the hand that they've now decided they don't want to do the production of it, because they realize if they produce too many of them, they're having some sort of mechanical design issue that they have to resolve. And that is, there's something about the actuators that they need to improve the design of so that they're more robust and they don't overheat. Or it might be something more dire than that, is that they may be thinking about, and this is what surprised me, is that we saw that post from Elon, it just seemed like the design review on that. I was like, wait a minute, I thought you guys had like this design for Gen 3 done like last year. And now suddenly here we're in June, July of 2025, and it's like, oh, and it's going to be great. It's like, okay, again, It's like we're being teased about this generation that we're not seeing. And I'm wondering if there's going to be a radical change in the design that could take more than 2 months. Because if they're just talking about we're trying to fix a couple of design issues in here, or they're completely rethinking the design of the legs and the hips, which means they could be, after careful consideration, saying, maybe we don't want those linear drives after all. That was the problem with RL. That may be the reason why it's not walking fast enough, and they realize that their kinematic design for the hip is going against what everyone else has figured out. And I think I may have mentioned it once or twice here. I did an analysis back in the spring of the different hip designs and the order of operations that you have with the hips. And everyone's first generation hips was attempting to do something where the flexion of the leg was going to be at the bottom of that serial linkage. So they all were going with something that I call like the ARF, that you have abduction, rotation, and then flexion last. And that's what Tesla has done in their design. And that's what a lot of the others were kind of chasing after, something similar, either an ARF or an RAF kind of design. But after they tried to do it, they realized how difficult it was to package that. Everyone's second generation design went to a completely different hip. And this is the FAR design. This is flexion, abduction, rotation, because I realized it's closer to the way the human hip works. And this whole idea that we don't want the flexure to be first because it has to carry the mass of all the other things, they realized that wasn't a problem. The other thing that's happened in the past 2 to 3 years is rotary actuators have got much better as far as torque, their torque capability. So, and I've seen this before. Back in the 80s, industrial robots were using ball screw drives, which are basically linear actuators to actuate a rotary joint, because the motors at that time, that was the only way you could get the strength and the torque that you joints. But then by the late 80s, early 90s, they were able to package those things enough that those ball screw drive designs went away. These linear drives, you didn't need them anymore. So the same thing is happening here, is that the first one that everyone's using, they're like, oh, nowhere, not enough torque, we have to use a linear drive. Now they're all realizing that. And if you move to that, the supply chain will be a lot better for that, because they can help those things out a little bit more easily. Now, the pluses and minuses is that the rotary drives, especially the harmonic drives, are only about 70% efficient. Linear drives are 90% efficient. So from an energy standpoint, there is an advantage to going with them. The other is that harmonic drives can be a little bit subject to shock and vibration. So over time, you can get into your mean time between failure if it's exposed too much to that. So depending upon how well those are made, they may not, let's say, have the robustness. So I think this is kind of what Tesla is trying to figure out right now. Is like, do we continue with a design where we continue to have the linear drives in the legs, where basically all your shock and vibration is coming from there, right? From the walking, because it will be more robust. Or do we pivot like everyone else has done, no pun intended, and go to rotary drives and redesign the hip completely? But something like that is probably not a 2-month event. I mean, you could come up with a design in 2 months and have something out there, but you still have all the learning, all the debugging, and everything else. It takes a lot longer.
Yeah. And Gustav, from a biomechanical point of view, I mean, considering that the world is built by humans, for human interaction, biomechanical interaction, how do you see, I mean, is the hand enough? Is it ready to deal with most, that 80-20 ratio of use cases?
I mean, we've talked about it before, and I think the claw is enough, basically. I mean, there are so many functioning versions of KugaBots or whatever you want that can do a lot of labor. You just need to attach it to the humanoid. And I mean, this thing, it didn't look like this in the beginning. I mean, it took billions of years to evolve our hand, and our ancestors, if you believe in evolution, they managed quite well. I mean, sure, they didn't reach human scale or capabilities until the last few 100,000 years. But I mean, you don't really need that to do most work. So I still think durability is one of the most important, and keep it simple. There's a reason why a lot of the prosthetics that are used by humans are quite basic in their build-up when it comes to human hand prosthetics. It's not tendon based. It does not have a lot of opposition. You set your thumb in this position, or you twist it, and now it's in an opposable position, and your fingers do not adduct in those. It's just a flexion extension. And sure, they are not that dexterous, those hands, but they are functioning and people can use them. And we saw this old clip of prosthetics from 100 years ago and how people use them quite dexterously, even if they are very basic hooks or claw shaped. So I don't know. I like the idea of going the full, getting as human-like hand as possible, but not on the expense of having the whole Optimus project kind of tumble.
And there's so many other use cases. I mean, this is Atlas from Boston Dynamics. Again, I think it's got a type of a claw hand. I think it's got what, 3 phalanges or 3 fingers. Yeah. So, I mean, it can still do a lot with just 3 of them. You don't need to replicate the human hand and the dexterity and finesse of the human hand to get a lot of work done.
Yeah, in theory, you can get by with 3 fingers because just like a triangle with 3 fingers, 3 points, it's very, very stable. However, for greater stability, it's nice to have a 4th digit in there. There's a reason why our chairs have 4 legs instead of 3 legs. In theory, it would work with 3 legs, but they tend to tip over a lot. So a lot of times when you're grabbing something, having that additional digit in there will make sure that you're holding on to it better. So there are reasons why, but yes, in principle, you get away just with 3 digits. A lot of people do. Gustav certainly has a lot of experience with that.
I mean, the construction of a hand which has no fingers, the things you're after is the tripod grip and your policization or having a thumb. So 3 fingers and a thumb, and then going for stability rather than mobility. So the CMC joint being stiff, for instance, is more important than having it very mobile and not being able to grip with the strength. So tripod, policization, like having a thumb, and getting it stable and strong. That's like the most important. Then, of course, sensibility, or what do you call it, the sensory input is, of course, extremely important. If you don't have that, you won't use your hand. It will just be on the side. So if you lose all sensation in your hand, it's a useless tool almost. So, but tripod, stable, and the thumb to be able to oppose. That's what we try to recreate.
And so there you have it. Probably the mistake that almost every humanoid bot company is making right now is they haven't hired a hand surgeon. And I mean that sincerely.
Which is expensive,
Really, they should hire a hand surgeon and talk to them about their experiences of people that have loss of mobility. What are the important joints? Everything else is going on there, and they will probably be able to give the honest assessment of like,
what's the minimum viable hand?
This is I know what it is. What is it you wanted to get done with the hand? You wanted to play the violin? Oh, okay. I mean, you're going to need all this mobility, but if they don't need to play the violin, if they need to be doing other basic chores around the house or even working in a factory, I can tell you exactly what they have. You've got the data, you've got the experience, everything. The same thing, I would also hire some physical therapists to go through and do a lot of gait analysis, looking at the movement on there and how human-like is it, and what you actually. So and they're fairly easy to find, I think. Here's around anywhere. So that's kind of the practical experience. Is that there may be a lack of maybe getting that practical experience of thinking that, oh, we're engineers, we're so clever, we can figure everything out. And what you really need to do is sometimes talk to people that have the data and have years of experience.
Yeah, absolutely. Well, I guess that's a lot of stock taking we've done with Elon and his companies, and especially the Optimus production line, where it stands, the challenges. I don't know. Do you think they could turn this around this year, or are we going to see these problems flow into next year, especially when you can look at supply chains, which have their own complexities?
I don't expect to see anything this summer. I mean, it's earliest that in the fall that I think we might get some sort of update. There was some rumor about they might show the Gen 3 at the shareholder meeting. At this point, the shareholder meeting has not been scheduled. I tried to find out when it is, and technically, based on the bylaws, it can't be later than 60 days after the last previous year's shareholder meeting, which was like early June or mid-June. So I think it's something like, but they can ask for an extension. So it might be August 12th is when it's going to be, but we haven't heard a peep about when it is. It's rather surprising. I think we would have heard by now when it's going to be.
What do you think they're kind of waiting to showcase? Is it the new vehicles, the cheaper models, Tesla models, maybe a new version of Optimus?
Maybe. But I mean, again, I don't think the shareholder meeting is necessarily the place that you showcase your product. That's been mentioned time and time again.
Or at least talk about it.
Yeah, they may talk about it, but I'd be very surprised. It's always, it should be its own separate event. And again, they have to lock that down pretty quick, which means it's putting a lot of pressure on the team to come up with something on that particular date. Whereas if they say we'll reveal it when we're ready, might be kind of a better approach. So I would suspect that we won't really see anything major, a new update until probably in the fall.
Interesting. Well, if Elon can keep his focus on his companies and get out of these spats with President Trump and disengage himself from, it's just, I kind of see he's coming from a good place, right? Let's just say that. Whatever he's trying to do, he sees a problem, he tends to focus on it in a way that I don't think any of us would be able to. And he kind of finds it difficult perhaps to disengage, which is a plus, which is what really Elon is all about and what differentiates him and sets him apart from all other CEOs. The fact that he can really, really drill down and focus, and at the same time multitask at a level that is just superhuman. But I feel personally, and I'm saying this as a Tesla bull, I think these distractions are getting in the way. And I think I'm not alone. I know, Scott, you'd rather not comment on the politics of it. But I think I can speak for myself that it's time that Elon gets back to focusing 100% on his companies. Because in the larger scheme of things, these are just, sideshows. Trump's going to be there for another 3.5 years. There's going to be a new president. That's the way the American system works. Let's just get on. There are bigger fish to fry. There's a lot more at stake, and especially from the viewpoint of investors like me, you need to really focus on the big picture, which is autonomy, which is humanoids, which is
Mars.
Getting to Mars. Yeah, and I mean, in the larger scheme of things, in the long run, this is not even a sideshow.
That's if Mars doesn't get hit by an interstellar object later this year.
There's a new one there.
Oh yeah, the one coming.
Yeah, it's amazing. It's like yesterday they discovered it and they showed a brief orbit of it, and it was like between Mars and Jupiter. Yeah. And now it's like they get more data last night, and it already moved that it's going to go inside the orbit of Mars. But then when you actually look at the simulation, well, wait a minute. When it crosses the Martian orbit, it's like right when Mars, it's going to be darn close to Mars.
So maybe interstellar travelers will inhabit Mars.
Clearly need more data. But that seems to be mighty darn close. What's going on? But,
yeah,
there's a friend from Alpha Centauri will get there before.
Yeah.
They colonize before we do.
Maybe they're going to come and bitch slap Elon and say, "Hey, listen, get down to work."
Yep. Yeah. Exactly. Yeah, they're going to nuke Mars for us. Yeah.
Yeah.
Terraform
it.
Yep.
All right. Great. Wonderful having you. We're going to end the stream here. Thanks, everybody who tuned in. Be sure to like and subscribe and keep those comments coming. We always love to hear from you guys. Whatever you have to say, as long as it's palatable. Keep it on point, on topic. Thank you, Scott. Thanks, Gustav.
Till next time.
Thank you. See you around.